A wonderful good morning, ladies and gentlemen, here at the Technical Forum at the group exhibit Hydrogen, Fuel Cells and Batteries, here at the Hanover Fairground in the year of 2015. Every 15 minutes, I invite you to enjoy interesting presentation concerning the hydrogen industry. Also, I'd like to invite you to have a seat, come and enjoy and relax here and have some complimentary drinks all on the house. I'm excited to present to you the first topic of the day. It's demonstration of high efficiency carbon negative energy production, BioZEG, and what ZEG stands for will the Managing Director of ZEG Power, Dr. Bjørg, Andresen, explain to you. Big hands, please.
Thank you for the introduction. I will first give you a short overview or short introduction to the ZEG technology, then a little bit about the company, ZEG Power, the BioZEG concept, and finally the 50 kilowatt demonstration plant we are running. So the ZEG technology, zero emission gas, is then technology for high efficient co-production of electricity and hydrogen from hydrocarbon gases with integrated CO2 capture. We have a solid oxide fuel cell producing electricity, and the fuel cell is also producing waste heat, high temperature waste heat, and we use the waste heat for hydrogen production in a modified reforming reaction. We add a solid sorbent, calcium oxide based sorbent, in order to remove the CO2 in a carbonation reaction. And in fact, we need a high temperature for regenerating the carbonate. And it is the thermal integration of these two basic technologies, the reforming reaction and the SOFC, that is the ZEG technology. And if we are able to have a very close thermal integration, we get a very high overall energy efficiency, more than 5% producing electricity and hydrogen with CO2 capture. This work started as research for almost 15 years ago as a joint venture between the two Norwegian research institutes, Institute for Energy Technology at Kjeller, Oslo, and Christian Michelsen Research in Bergen. And we then have a unique patented technology. It's the system integration that is patented, as well as technology applications. Some of our main milestones are then technical economical feasibility studies that verify this very high overall efficiency. That is on large-scale power plants producing 400 megawatt of electricity and various amount of hydrogen. The basic technology elements, that is the hydrogen production and the SOFC, are verified in lab scale. And with respect to the hydrogen production, we have focused on reactor technology as well as development of solid sorbent for the CO2 capture. On the SOFC stack, it's focused on stack development. We had a 2 kilowatt demonstration unit some years ago where we produced hydrogen to fuel the SOFC, and we captured the CO2, but 2 kilowatt plant was too small in order to demonstrate thermal integration. Last year we finalized and commissioned a 50 kilowatt plant running on biogas, and we call that the BioZEG plant. So the strength then of this technology is the very high overall efficiency. If we compare with state-of-the-art gas power plant, has about 60% overall efficiency. If you add amines for CO2 capture, the overall efficiency is reduced to 50%. We have potential of 75% with CO2 capture without any additional cost. High purity CO2 is delivered ready from the plant for further sequestration or industrial use. So, but even if we don't do anything with CO2 afterwards, with our technology we get more energy and less emissions, less CO2 for each energy unit that is produced. And If we are using biomass, this will permit then carbon negative solutions. Other strengths of this technology is then the flexibility. All types of carbon-based fuels can be used. We are able to vary the product composition, that is the ratio between the electricity and the hydrogen, of course dependent on the design limits. And the technology is also module-based with various applications as well as various scales. So the company ZEG Power is then also a joint venture established in 2008 between the two Norwegian research institutes. And we are situated in Kjeller, close to Oslo in Norway. And the main objective is then to design, build and verify this technology for commercial power plants of increasing size and complexity. So main deliverables will be concepts and detailed design of these plants for selected applications in varying sizes. What we call the BioZEG concept is then the possibility of using local cheap resources such as waste. That could be biogas from wastewater treatment plants or clean landfill gas in order to run this plant. And as CO2 capture is included, then it permits carbon negative energy production. The CO2 can be used for further industrial purposes such as growing algae or also other chemical compounds. Of course, you know a lot about what hydrogen can be used. Direct for transportation is an increasingly interesting approach. So this is then the facilities where we are testing our plant. Hyen og Lillestrøm Test Center for Hydrogen Technology. And this is a unique test center just outside Oslo, where we are able to demonstrate both systems and technology. The main idea is to demonstrate renewable energy and hydrogen production with local hydrogen supply, refueling of fuel cell vehicles. We also are demonstrating hydrogen compression and also then distributed power with fuel cells. The key technologies that are tested are, in addition to the ZEG technology, water electrolyzing, metal hydrides and also hydrogen purification. Over 50 kilowatt plant is then a demonstration of green production of hydrogen and electricity. We use biomethane made out of waste from Oslo city. From a technical point, the main objective for the plant is to demonstrate this close thermal integration in order to get a high overall efficiency. In this case, we are able to get about 70% overall efficiency, producing then 20 kilowatt of electricity, 30 kilowatt of hydrogen, and delivering a separated clean CO2 stream. This is then the process flow of this plant. On the left side, you see the reformer system. That is for the hydrogen production, a reformer and a regenerator. And on the right side, we have the solid oxide fuel cells. In this case, the fuel cell is about 800 degrees. So we also need an afterburner in the system in order to get enough temperature to regenerate this carbonate. And in addition, this plant is not an optimized ZEG concept. We are able to run both systems separately, so then we also have a pre-reformer in order to run the SOFC. A little bit about the basic technologies. The hydrogen production we call sorption enhanced reforming. The basic idea with this modified version of reforming is then to get the CO2 out of the system. And then we utilize the carbonation reaction, and then we add this solid sorbent. the process is simplified. We doesn't need any shift catalyst. With the reforming and the shift reaction is in one single step. So we produce hydrogen in one single step. It's illustrated in this reactor system here, and then we form carbonate that has to be regenerated back into the oxide, and then we have a continuous process. And it is, as I said earlier, the carbonation or the decarbonation reaction, we need this high temperature heat. So this is then the reactor system. To the left we have the reformer, and to the right we have the regenerator. This is then a double bubbling fluidized bed reactor system, where we are able to produce hydrogen in a continuous mode, also removing CO2 as a part of it. In this case, we use commercial reforming catalyst and a dolomite that is mixture of calcium and magnesium, with calcium as the active compound in order to remove the CO2. This is just an example of an early batch test of the reactor system, illustrating one of the basic ideas with this sorption enhanced reforming. When we remove CO2 as a part of it, we get a very high yield in one single step. In this case, we have 94 volume percent of hydrogen and 0.6 volume percent of CO2. So this is just a batch test, successfully batch test. Then at this time we are running this system in a continuous mode. The other basic technology in the system is then solid oxide fuel cells. And in our plant we have a tailor-made SOFC made by CMR Prototech with stacks from Plant C, Fraunhofer IKTS. And in this 20 kilowatt module we have then altogether 24 stacks made of 30 cell plates with metallic interconnects. And in these test facilities we are producing hydrogen for refueling and power to the grid. So this is just the first power production to the grid from our system. Main ongoing activities are then to use this power test plant for optimizing and get operational knowledge. That's really important in order to take this technology to a larger scale. And we have also started the upscaling to from 50 to 400 kilowatts. We are also working with what we call the BioZEG concept development, that is to finalize to make industrial applications, find industrial applications and customers that need both hydrogen and electricity. And if we are able to include CCS or CO2 capture, a key part of it, it is a successful concept. Thank you for your attention.
Thank you for this wonderful and interesting presentation of zero emission gas power. We do have time for only one question. Unfortunately, we are running out of time. So is there a question from the audience?
Thank you very much for interesting presentation. One question, well, I'm allowed only one. I have two, but anyway, we'll talk about it afterwards. You only talk about CO2, the production, but you mentioned that waste could be the feedstock. What happens to other contaminants like sulfur, nitrogen, other things?
Okay, we have to clean up a biogas in advance for the sulfur components. So but we don't need to remove the CO2, but we have to remove the sulfur compounds.
All other questions can be taken to the booth B60 of ZEG AS. Thank you very much. Big
Thank you.
hands for Dr. Bjørg Andresen. In only 2 minutes' time, we'll have the next topic, long-term energy storage for on- and off-grid applications. And for that, we'll be hearing the CEO of Hydrogenious Technologies, Dr. Daniel Teichmann, in only 2 minutes' time.